Imagine a hurricane. Now imagine that hurricane is so large you could drop the entire planet Earth inside it, and it wouldn't touch the sides. This storm has been raging for at least 300 years. On Earth, storms last days, maybe weeks. On Jupiter, this one has outlived empires. This is the Great Red Spot. It is the largest storm in the solar system, a high-pressure region of screaming winds. And the strangest part is that we still don't fully understand why it exists. Astronomers have been watching this crimson eye staring back at us since the invention of the telescope. Generations of humans have been born, lived, and died, while this single storm continued to spin. But for centuries, all we could do was look at the top of the clouds. We had no idea what was powering it. We didn't know how deep it went. We didn't know why it was red. And we didn't know that it might not last forever. Until recently, the Great Red Spot was just a two-dimensional mystery, a flat oval on a striped ball. But that changed when NASA sent a spacecraft not just to look at Jupiter, but to dive into its atmosphere. In 2011, NASA launched Juno. Unlike previous missions that kept their distance, Juno was designed to be a daredevil. Its orbit is highly elliptical. It swings far out into space, then dives in close, skimming just a few thousand miles above the cloud tops, screaming past the planet at 130,000 miles per hour. These dives returned the images unlike anything we have ever seen. Previous telescopes showed us a beige and red striped planet. But Juno shows us a world of oil painting turbulence. Look at the detail. These aren't just clouds. They are ammonia and water vapor, stretched and twisted by jet streams moving at hundreds of miles per hour. And as Juno glided over the southern hemisphere, it turned its eyes toward the Great Red Spot. Up close, the spot isn't a calm oval, it is a violent mess. At its edge, the winds are racing at 400 miles per hour, which is twice as fast as the strongest Category 5 hurricane ever recorded on Earth. But inside, in the very center, it's almost eerily calm. Juno discovered that the storm is actually warmer at the top than the surrounding atmosphere. It is an anticyclone. On Earth, storms spin around low pressure. On Jupiter, this monster spins around a center of high pressure, towering above the surrounding cloud deck. It is so tall that it rises higher than the clouds around it. Imagine a mountain of wind, taller than Everest, spinning endlessly. But the most shocking discovery wasn't about how tall the storm was. It was about how deep it went. For decades, planetary scientists argued, was the Great Red Spot just a surface scar? A shallow storm floating on top, like a leaf on a pond? Or did it have roots? Juno carried an instrument called a microwave radiometer. It allowed the spacecraft to peer through the thick cloud tops and see the structure underneath. The data was staggering. The Great Red Spot is not a surface feature. Its roots plunge downwards for hundreds of miles. To put that in perspective, Earth's oceans are, on average, only 2 miles deep. You could stack dozens of Earth's oceans on top of each other, and you still wouldn't reach the bottom of this storm. This depth is critical. It means the storm is being fed by heat coming from deep inside the planet. Jupiter still retains immense heat from its formation. It radiates more energy than it receives from the sun. This internal furnace drives the weather. The Great Red Spot isn't just a weather event. It is a chimney. It is channeling heat from the interior up to the surface. This explains its longevity. Earth's hurricanes die when they hit land or cold water. They run out of fuel. But Jupiter has no land. It is gas all the way down. There is no friction to stop the wind. There is no continent to break the storm, so it spins and spins. And yet, despite this infinite fuel source, something is wrong. In the late 1800s, the Great Red Spot was estimated to be 25,000 miles wide. It was an elongated sausage shape, capable of swallowing 3 Earths side by side. By when Voyager flew past in 1979, it had shrunk to 2 Earths. Today, it can barely fit one. Amateur astronomers recently noticed flakes or blades of red material peeling off the main storm, dissipating into the jet streams. It looked like the storm was unraveling. Concern spread in the astronomy community. Was the Great Red Spot dying? Would we be the generation that watches the most iconic feature of the solar system disappear? Current data suggests something more complex. While the storm is shrinking in width, it appears to be getting taller. Like a figure skater pulling in their arms to spin faster, the spot is conserving its momentum. The winds are speeding up as it tightens. It isn't necessarily dying, it is concentrating. However, most fluid dynamics models suggest it cannot last forever. Eventually, the turbulence of the surrounding jet streams may tear it apart, or it may simply run out of thermodynamic energy. It might persist for another decade or another century, but it is not immortal. There is something humbling about the mortality of the Great Red Spot. We look at the planets and think of them as static, unchanging marble statues. Mars is red. Saturn has rings. Jupiter has a spot. But the universe is not a statue. It is a process. Saturn's rings are temporary. They will rain down onto the planet in the distant future. Mars was once blue with oceans, and Jupiter one day will likely be spotless. Perhaps a new storm will rise to take its place, or perhaps the band will settle into a calm beige stripe, erasing the evidence that a monster ever lived there. We are lucky. We evolved the technology to see space at the exact brief moment in cosmic history where this beautiful, terrifying red eye was looking back at us. Thanks for watching. If you want to understand what lies beneath the ice of Europa, or how the universe actually ends, make sure you are subscribed. See you in the next one.